Okay, so as usual, I will start us off with the demo. It's of this app called Prismantix, which allows you to generate very realistic synthetic test data. And that will lead us into three topics. First one is, what have I learned from now rewriting this 3 times? And was that rewrite worth it? We'll talk about this idea of ontology-maxxing. And so when that dude from the Palantir Twitter makes some merch with that on it, remember, you heard it here first. And the last item is, how do you really get exponential, non-linear progress using AI? Okay, so I'll start us off. The first thing you'll see here is a schema browser. This effectively is a drill down into the details of your ontology. Okay, it's going to have information about the connections. It's going to show all the different objects, the relationship, even including things like system fields. Okay, so from there we jump into Prompt Lab. So what this allows you to do is you can scroll through, pick an object. I'll say, let's pick site. Okay, that's a short one. That's going to show you everything that has been derived from the definition, the ontology definition. And when I say ontology, I literally mean ontology-as-code definition of this object. That's going to convert into a set of rules as well as details on the data type, which is effectively your prompt. And then if we have a more involved example, it will also include the relationships to others. And so this view allows you to test a example in isolation. Okay, and maybe just to quickly show you, we will try it with this. And while that's running, I'm going to show you a couple other nice pieces to this. So it uses OpenRouter or the Foundry AI NPM package that I made a video on, I don't know, like a month ago. This is what, this is built on top of that as well. But here, we've seen the results, right? Like you can see the full output, you can see some metadata about it, and there's even like a sentry trace, but we'll probably look at one of those traces a little bit further down. So, okay, what do you want to do from here? Well, obviously you want to be able to generate this in bulk, and you want to be able to have it where each object that you generate and the content of that feeds into the prompt for the next item, okay? So let's go to that, and we'll start a new plan. Yeah, that's fine. We'll pick a model. Honestly, I like the 3.1 flash light. So we'll pick that, and we'll say Prismantix demo. All right. So I will keep it maybe a little bit shorter and just do these. Maybe deviation, I'll maybe skip one and see what happens. Yep, if you skip something, right, for example, if you have an investigation, you typically need a product complaint or a deviation, or we have a deviation, but you need the actual complaint as well, and so it's going to call that out as missing. So I'll remove that one, and this looks reasonable. Maybe I'll drop this down a little bit to maybe 30 so it completes faster, and let's kick it off. Okay. What's going to happen here is it has derived the optimal order for these things to be generated, exclusively using the relationships between these ontology objects, and it will systematically run through them. And for larger ones, maybe this one is a good example. Yep. It will actually chunk it up. And what I mean by chunk it up is if you try to ask an AI to do too much at once, it's not going to do a great job. And so this allows, one, for some parallelism, and two, it allows you to keep the model in its happy place. And it's also useful if you're passing in a bunch of linked entities. If you can have it focus on, let's say, just the equipment that is associated with this specific site, it's probably going to do a lot better. All right, well, that is finished generating, so that will lead us into the Data Explorer. Okay, and so within this, you can see each of the objects, right? All of their fields, all their relationships. So let's say that we want to go into this batch. You can now see this. You can see who's assigned to it. You can see the site ID. You can, again, click through all of these, and it will like navigate you through those details. And this is just like a quick explorer for be able to visualize and understand it. And if I'm being honest, the number one view was really just a good way for me to like really test it and like make sure that the results looked right in isolation before I went on to like a more involved batch run. All right, so this has taken us all the way through generation. The last item is going to be, okay, now that you have this data, what do I do with it? How do I get it out and actually start like using it to seed my system? And that's going to lead us into item number 5. Okay, so let's go here. We've already generated a key. Well, there's a quick start guide that I've made for using the CLI. All right, so I'll copy this and we'll jump into an actual download. Okay, maybe let me zoom a little bit. And if you've done a prior generation, you just want to download, that's fine as well. It works just fine for that. Let me cancel this out so it's not distracting. Okay, so it has said it has finished. Okay, so what is in here? Well, we can find out. Oh, it's a... Okay, fine. I will just do it in Z. Okay, so you can see everything here. You can see each of the individual CSVs, and these have the raw content, so this can be just directly seeded. I've thought about like making generations that seed it into like a Postgres database or other things like that. It's honestly just not a priority, so this will work for right now. Okay, so where does that take us? Well, first thing I wanted to touch on is like how does this actually work? All right, well, behind the scenes, it takes your Palantir ontology-as-code, and when I say that, I mean if you're familiar with the ontology-as-code syntax, this should look pretty familiar. The one caveat that I will say is the actual Palantir ontology actually does have an example values field. The ontology-as-code like package definition does not, and so I had to, let's say, effectively like patch package it, and I've created another variation of it which extends it a little bit, but it's entirely just based on it's based on like this version of the upstream OSDK/maker if you're familiar with that. Okay, so that takes us here, which is we have the Palantir ontology-as-code. Well, from there, it runs a series of generators that then create the convex schema, the like metadata linkage information, as well as define a generation plan sequence, which is kind of that order that you saw on that prior screen. It will then pump them through an LLM. I'm using convex workflows and like the work pool for rate limiting and like modulating the throughput, as well as workflows for like retries if there's like a transient issue. But let's say that we've invoked the LLM, we've generated it for the full content. Well, it then stores that data, and it's storing it in actual like proper convex tables. And then from there, we ran the CLI, which hits an API to export the data. Well, first, I'm not trying to directly commercialize this. Like, I see this as an enablement product. But other than the home screen, which I largely kept, I did rework this ship post at the bottom to, make sure the icons are perfect. But, other than that, like, it's a ground up rewrite. It was previously not a monorepo. It became a monorepo. It was previously Next deploying to Vercel. Now it's Tanstack Start deploying to 3 different Cloudflare workers plus Hano. The convex part stayed the same, but like even the ontology-as-code usage was completely new. It was a rewrite. Not only that, Because LLMs are like famously verbose, and they love their duplication. And the entire purpose of this was to go from like, in the prior version, there's effectively 3 representations of the data slash prompts. This version, I wanted exactly 1. Right? You could define your object and all the relationships once, and you get everything else for free. Well, because of that, I could not use, or I could not convince an LLM at the time to write a very significant portion of like that back-end code for me. Okay, and I'm not elitist about, I never use an AI to write code, or if I do, it's the highest quality, handcrafted, artisanal. I've code reviewed it 4 times. Oh, no. If you don't believe me, go look. A couple weeks back, I posted a video about pulling in like 11.5 grand worth of agent session data into Databricks. Yeah, there is no chance that more than a third of that was better than like 2-month-old Wonder Bread. There's nothing artisanal about it. And I'm telling you this because I want kind of like the lesson to stick, and that is, if you are not someone who like loves the craft of programming and all you're really interested in is just like max productivity, there is no chance that someone who is just like fully removed from the problem, copying and pasting prompts between sessions, running in a Ralph loop, will in a period longer than like a couple months achieve more interesting, valuable work than someone who is actively learning from the implementation and learning from their work with AI. And I'll give you a couple of like meaningful examples to this. And so for context, I have used NX, Convex, Palantir OSDK. I've used all of those at minimum of 10 projects, probably more like a minimum of like 20. Okay, and so I'm not new to this, and even so, like this project and the act of having to solve a really difficult project where I knew the LLM could not meaningfully help me, but at the same time, having the LLM to very quickly get me up to speed on topics that I was not super familiar with has like fundamentally changed and made me rethink about parts of how I solution and solve like really nasty problems that I otherwise did not have a good solution for until now. Okay, and another good example is like all of the text to CAD work that I've done. The LLMs are pretty useless on how to design the harness for it, because this stuff is like so out of sample for them that like they will suggest solutions and ideas that are completely counter to what should be done. Like it's the Jim Cramer effect, but for software. All right. And so I'm gonna quickly talk through a couple of the examples. And the reason I picked these are, one, they're large enough that I think you will understand that these are not learnings that will become irrelevant in a year or 2. Okay. And more importantly, you'll probably start to see the effect of these learnings in a couple of upcoming videos, all right? And you'll know where this ultimately came from. All right, so the first one is the role of NX and what NX does to projects. So I previously thought of NX as something that was limiting, right? It was a tool that you reached for when you had a large team where you needed to, one, get faster builds, and when you wanted to practice constraint and restraint. That has changed. Because Convex does not have like native TypeScript support, or like it doesn't have like first-party support or even community support, neither does like any part of like Palantir OSDK or like any of that. I previously thought that I would have a hard time working within it, and it would be something that would limit me, but would ultimately make the solution better long term. What I have realized is I was able to build something pretty quickly too, that allowed me to understand what was affected, to be able to on-demand generate types for the next part of the solution that didn't have like an explicit dependency on that other package. And so it has enabled these use cases where I can pick tools for a job that just make sense, right? And to give you more like a follow-up example, within like a lot of the text to CAD work, Python is best for a lot of like the image rendering or the model rendering because it wraps like some underlying C++ code, and because a lot of it is like data science heavy. At the same time, obviously you want TypeScript for web, and you want Go for things where you need high concurrency. And so the learnings that I took from here about it doesn't really matter if these things are quote unquote supported or if there is like an explicit linkage in the language. As long as you can define the boundaries and create the right generators and like automated linkages, you can do whatever you want to. And so I now have projects that have TypeScript, Go, Python, even one that has like a tiny bit of Rust, and I hate Rust. And so like it has just fundamentally changed how I think about problems, and it's done it in a much more freeing way where I'm just like, I can do whatever I want, and it's awesome. And then the next one was in the process of having to understand the OSDK like maker package well enough to be able to use it as a foundation for everything else. I ended up going so deep. Like I reverse engineered how their generators like ultimately produce like the how you go from like the IR representation into the OSDK SDK version, and how you go from that into like whatever that JSON format is that you like insert into like the ontology, or if you ever do like an ontology export, like there's all these different formats and how they go between them, how their code is structured and maintained, and it ultimate like in this like frenzy of reverse engineering, I found the Palantir Terraform repo, which I did not know existed, and I spent like 2 days like actually straight just like really understanding it, and like I have such a foundationally good understanding now of how Palantir works behind the scenes, all of the individual services that like make up this platform, that it is just like it is resulted in me saving so much time on things that I would normally be stuck by, because not everything is documented, right? Obviously, there's tons of private source within Palantir, and unless you understand how things work foundationally, you'll just feel stuck. And I no longer feel stuck because I'm like, yeah, I know how that piece works, and if I'm ever worried about it, I'll just go find this one repo, and then I'll fundamentally go have an AI go check out a little part of it, and now I can solve my problem myself. It's amazing, right? And so like that is what I mean by these kind of like caliber of problems. I'm gonna skip the depot one for now, but I just want to make sure that they're meaty enough. And like at the same time as I was like starting to realize this, I saw this article that came out, and also that Theo guy from T3GG, he posted a video on it too. It's like there's a couple of good lines here, which is a higher level of ambiguity is not a higher level of abstraction, and like you have to remove the temptation, or maybe not temptation, but like social pressure to say, it's important that I function as a manager of agents. No, it's important that you understand what's happening and you solve meaningful problems. We don't need more cluttered, shitty Next.js or React apps cluttering up GitHub and slowing down my builds. That's not what we need. Sorry, that was a little bit pretentious. But the next one is coding is planning. And I actually don't exactly agree with this because I don't think this way. But I want to share the quote, and I'll explain the version that applies to me, which is when working on something new or something challenging, me typing out code is the process by which I figured out what we should even be doing. And this is from Dax, the creator of OpenCode. Now, I don't I don't exactly think in that same way. Like for me, it's whiteboarding and it's actually reading docs. Like I read so many docs, even though I have an LLM that can analyze it, I still like reading the docs because I get ideas from docs. And like I see connections that other people miss. And the same thing is like I also like learn a lot by like reverse engineering or exploring other code bases to figure out how things work. And that has given me the most foundational understanding of like really complex systems, even historically. So point being is it's different for everybody, but I seriously doubt that you are getting value from just like talking to the agent if that's all you're doing and you're not doing your own independent exploration. And so I will leave you with a quote. I'm not famous enough for this to be a real quote, but I put my name there anyways in the hopes that one day I become famous enough that someone looks back and like, that dude was right. But true exponential progress requires you to learn at or faster than the LLMs. And that's what you should strive for. I'll see you guys in the next one.